They called him crazy. They said it couldn't be done. In the ruins of a world at war, surrounded by smoke, fire, and a relentless roar of aircraft engines, one man dared to defy reason. Mechanic Johnson, a man whose hands were scarred from years of welding, grinding, and repairing, stared at the twisted heap of scrap metal before him and saw possibility. While engineers in Stark offices calculated impossibilities on paper, he saw a challenge, a chance to breathe life back into a machine that had once dominated the skies. The P-51 Mustang, the pride of Allied air power, a symbol of freedom soaring over enemy lines, lay dormant, and Johnson was determined to awaken it. It was 1944. The war in Europe had reached a fever pitch. Allied forces stormed the beaches of Normandy, pushing against the German war machine with a mixture of strategy, courage, and sheer desperation. On the Eastern Front, the Soviets clawed back territory with unrelenting ferocity. Every battle, every advance, depended not just on men but on machines. Aircraft, tanks, and artillery were the lifeblood of modern warfare. And among these machines, the P-51 Mustang had carved out a legend. Fast, agile, and armed with the deadly precision of the .50 caliber Browning machine guns, the Mustang was the guardian of bombers, escorting them over hostile skies, turning the tide of aerial combat. But engines fail, steel fractures, and in the chaos of war, spare parts were scarce. Factories in England and the United States struggled to keep up with demand, while German bombing raids threatened supply lines. It was in this context that Mechanic Johnson faced a task that no one dared imagine. He was not an engineer with degrees framed on a wall, nor a scientist calculating every torque and cylinder. He was a mechanic, trained in the trenches of everyday repair in garages and workshops, learning the secrets of metal through trial, error, and intuition. And yet, the challenge he faced was monumental. Could he turn a pile of salvaged, broken, and twisted metal into a fully functional P-51 engine, capable of powering one of the most advanced fighters of the era? Johnson's workshop was modest, a single shed tucked at the edge of a small airfield. Inside, the smell of oil and burnt metal was thick, the floor littered with wrenches, pistons, and the remnants of engines past. The scraps he had collected were from crash sites, bomb factories, and abandoned airfields. To anyone else, it was junk. Rusting cylinders, shattered valves, broken crankshafts. But to Johnson, every dent, every warped piece of steel told a story, and more importantly, hinted at a way to rebuild what had been lost. The stakes were not just mechanical. Allied pilots depended on their aircraft for survival. One engine failure could mean the difference between life and death, between victory and disaster. Johnson knew that if he failed, it wouldn't just be a personal embarrassment. It could cost lives. Yet, the audacity of his vision burned within him. He believed that the true measure of skill was not in avoiding the impossible, but in confronting it head-on. And in a world torn apart by war, audacity often became necessity. Engineers who first heard of his plan laughed. Madness, they called it. You'll never get an engine to run with these parts. They cited tolerances, metallurgy, and precision machining, elements that Johnson often had to improvise with. Tolerance gaps were measured in thousandths of an inch. Materials had to withstand extreme heat and pressure. And yet here he was, working with scraps that were bent, corroded, and broken. Yet, the very constraints that seemed insurmountable were what pushed him into ingenious solutions. Where a factory had standardized parts, Johnson invented workarounds. Where blueprints failed, experience guided him. He worked tirelessly, often late into the night, the glow of a single oil lamp illuminating his hands as they moved with confidence across metal and machinery. Each piece had to be cleaned, reshaped, tested, and sometimes entirely remade from raw materials scavenged from other engines. Pistons were polished, valves reground, and crankshafts meticulously aligned. He improvised tools when the proper instruments were unavailable. For Johnson, failure was not an option. It was merely a step in the process. Every spark from the welding torch, every clank of the hammer on metal, was a heartbeat in a larger, audacious rhythm. The resurrection of a fighter plane. The rumors began to spread through the airfield. Pilots whispered about Johnson, the mechanic attempting the impossible. Some dismissed it as folly. Others were quietly fascinated. If he succeeded, It would mean one less aircraft lost due to mechanical failure. But if he failed, it would reinforce the engineer's warnings and add a cautionary tale to the already grim stories of wartime improvisation. And so, as the air raid sirens wailed in the distance, Johnson continued his work. He was not just fighting metal. He was fighting time, scarcity, and the incredulity of men who claimed mastery over machines. And little did anyone know, the first sparks of this madness would ignite a chain of events that would astonish even the most skeptical engineers, challenge the very definition of ingenuity, and leave an indelible mark on the history of aviation. What happened next would defy logic, push the boundaries of human skill, and reveal the extraordinary courage not just of men in the sky, but those on the ground who fought battles of steel and fire far from the front lines. Johnson's work was about to reveal that in war, sometimes genius comes not from the classroom or the laboratory, but from sheer determination, audacity, and a belief that no scrap of metal is ever truly worthless. And yet, as Johnson prepared for the moment that would decide the fate of his experiment, few could guess that the most critical test was still to come, a test that would either crown him a hero or prove the engineer's dire warnings all too true. The first challenge came not from the metal, but from time. Supplies were limited, and each day brought news of lost aircraft, failed missions, and pilots down behind enemy lines. Johnson knew that if he delayed, the lives of men in the air could be at risk. He also knew the stakes were intensely personal. If the engine failed in flight, the consequences would be catastrophic. Every adjustment had to be precise, every alignment perfect. Yet the materials at his disposal were anything but perfect. Rusted cylinders had to be reborn, warped crankshafts straightened, valves reshaped. Each task required skill, patience, and intuition honed through years of hands-on work, far beyond any technical manual. He began with the heart of the P-51 engine, the V12 Merlin block, an intricate dance of pistons, crankshafts, and camshafts. Johnson examined each piece as though reading a story. He could sense which components could be salvaged and which were beyond saving. Some had hairline cracks, others were corroded by rain and neglect, yet each held potential if treated carefully. He sanded, filed, and welded, often improvising repairs that would make trained engineers shake their heads. To him, it was not just metal. It was the lifeblood of a machine that had carried pilots to both glory and death. But Johnson faced more than physical challenges. Bureaucracy, skepticism, and even jealousy loomed. Engineers from nearby airfields visited, curious, incredulous, or simply amused. "Why bother?" they asked. "You'll never get it running. It's scrap, nothing more." Their laughter echoed in the cramped workshop, but Johnson welcomed it. It was fuel for his determination. He had learned long ago that ingenuity thrives where doubt is greatest. Every sneer, every shake of the head became motivation, driving him to push further, innovate harder, and trust in his instincts. There were moments when it seemed impossible. A piston that refused to fit, a crankshaft misaligned by mere fractions of an inch, tools that were inadequate for the precision required. Johnson improvised relentlessly, using pieces of other engines, melting and recasting metal, even handcrafting gauges and jigs to measure tolerances. Each success was tentative, each setback a reminder of the stakes. Yet slowly, with painstaking care, the engine began to take shape. The pieces, once discarded and deemed worthless, began to form a coherent whole. Amid the mechanical challenges, Johnson discovered hidden truths about the P-51 engine itself. He realized that the Merlin's design allowed for flexibility, that tolerances were strict but not unyielding, and that the engineers who deemed his plan impossible had overlooked a vital truth. A skilled mechanic's hands could compensate for imperfections in ways a blueprint never could. Johnson's work became a silent dialogue with the original designers, a conversation across time and space, where experience met theory and intuition bridged gaps that metal alone could not. As the weeks passed, rumors of Johnson's progress spread beyond the airfield. Pilots began to visit, peering into the workshop with cautious curiosity. Some offered advice, others quietly contributed spare parts. The atmosphere became charged with anticipation. Each visitor added pressure, but also hope. Johnson worked feverishly, knowing that every hour brought him closer to either triumph or disaster. And yet, The engine remained untested until it roared to life. It was only potential, a silent promise waiting for ignition. Then came the moment of truth. With the assembled engine mounted in a test frame, Johnson approached the ignition switch. Around him, the airfield was quiet, the distant hum of other aircraft a background score to a story that had been building for weeks. He held his breath, remembering every hour spent in welding sparks, every crankshaft painstakingly aligned, every piece of scrap transformed into something vital. The switch clicked. Silence. Then a cough, a sputter, a trembling vibration, and finally a deep, resonant roar, the sound of AP-51 heart beating once more. Johnson smiled, exhausted but triumphant. The impossible had been achieved. But even this success carried risks and mysteries. Observers were stunned. How could a pile of rusted, discarded parts produce power comparable to factory-built engines? Engineers arrived to inspect, their skepticism giving way to awe. Some quietly documented Johnson's methods, while others cautioned that such improvisation could never be replicated safely. Yet, for the pilots who would one day fly the aircraft powered by this resurrected engine, those debates mattered little. They would never know the countless hours of labor, the improvised tools, and the sheer audacity required to bring the Mustang back to life. Yet, beneath the triumph, tension lingered. War was not patient, and each flight of the rebuilt engine would carry its own danger. Johnson knew that a single failure in the air could erase all the months of work in an instant. Still, hope had been reignited. The P-51, once silent and broken, was now alive, ready to soar over the skies, and Johnson had rewritten the rules of what was possible when skill, intuition, and courage collide. And as the first test flight loomed, with a young pilot strapping into the cockpit above a war-torn landscape, Johnson could only wonder, would the engine endure the real test, or would the skeptics be proven right in the most dramatic, unforgiving way imaginable? The moment that would decide everything was approaching, and the world held its breath. The day of the test flight arrived like a storm on the horizon. The airfield was tense, filled with the anxious hum of mechanics, the clatter of tools, and the low murmur of pilots who had come to witness what many called a fool's experiment. Johnson stood beside the rebuilt P-51, the engine purring beneath the cowling like a beast awakening from a long slumber. Every bolt, every valve, every improvised piece of metal had been double-checked, triple-checked, yet he knew that no amount of preparation could erase the danger of the unknown. One misstep could end in disaster, and the skeptics would have their vindication. The pilot, a young lieutenant barely out of flight school, climbed into the cockpit. His hands were steady, but his eyes betrayed a mix of excitement and fear. The Mustang's canopy closed, and the roar of the engine filled the hangar with a sound both terrifying and beautiful, a symphony of power and precision born from scrap metal and ingenuity. Johnson wiped a hand across his brow, watching as the propeller began to turn, faster and faster, until the engine hummed with life, ready to lift its pilot into skies. With a signal, the Mustang rolled down the runway. Dust and gravel scattered behind it. The engine, born of scraps and impossible odds, responded flawlessly. The wheels left the ground, the plane climbing with grace and authority, a living testament to the skill and determination that had forged it. Ground crews cheered, some incredulous, others with tears in their eyes. Mechanics whispered in awe. Engineers who had called it madness now silent, forced to witness the triumph of intuition over convention. Johnson, exhausted and trembling, allowed himself a small smile. For a moment, the war, the fear, the uncertainty, all of it, faded away, replaced by the pure, unadulterated thrill of victory. But the true test lay ahead. The aircraft had to perform under conditions it was designed for: long-range escort, high-speed maneuvers, and sustained aerial combat. Johnson watched from the control tower as the Mustang disappeared into the clouds. Hours passed like minutes, each second stretching in suspense. Then, radio chatter crackled through the air. The pilot was reporting back. The engine held steady. Performance exceeded expectations. Maneuvers were executed flawlessly. The impossible was not only possible, it was perfect. What made Johnson's achievement even more remarkable were the subtle innovations he had introduced without fanfare. By reshaping certain pistons and adjusting the valve timing to compensate for material wear, he had created a variant of the engine that was lighter, more responsive, and surprisingly reliable under stress. These were secrets not found in blueprints or engineering manuals. They were born of intuition, trial, and an intimate understanding of metal that only years of hands-on experience could produce. In the quiet of his workshop, Johnson had done more than repair an engine. He had reinvented a legacy, proving that human ingenuity could overcome scarcity and doubt even in the darkest hours of war. News of the flight spread quickly. Across airfields and repair depots, stories of Mechanic Johnson's audacious feat circulated like wildfire. Pilots sought him out, mechanics admired him, and engineers, those same men who had called his project madness, began studying his methods in private, taking notes and quietly incorporating lessons into their own work. The P-51 engines rebuilt by Johnson and inspired mechanics would go on to escort bombers with fewer mechanical failures, giving Allied pilots a better chance of returning from the front lines. Lives were saved, missions succeeded, and a small but significant victory was etched into the broader canvas of the war. Yet, Johnson never sought recognition. He returned to his workshop, to the smell of oil and the clatter of tools, already imagining the next challenge. For him, the triumph was in the act itself, the resurrection of life from scrap metal, the defiance of conventional wisdom, and the knowledge that his hands had shaped history in their own quiet, uncelebrated way. The legacy of this achievement extended far beyond the airfield. In technical manuals and engineering lore, his improvised methods were eventually documented. In pilot memoirs, the reliability of the rebuilt engines became a footnote to survival stories over enemy territory. And in the hearts of those who understood the enormity of the feat, Mechanic Johnson became a symbol of courage, creativity, and resilience. One man, a pile of discarded metal, and a belief that nothing, not rust, not doubt, not the impossibility itself, could stand in the way of skill guided by determination. As the war raged on, Johnson's story remained a quiet reminder that innovation often arises in the most unlikely places. Factories, laboratories, and offices produced strategies and plans, but it was in the grime of a workshop, under the glow of a single lamp, that raw talent met sheer audacity, producing results no one thought possible. The P-51 engine, born of scrap and skepticism, roared not just in the sky, but into history itself. And long after the last Mustang had flown, after the war ended and the world slowly began to rebuild, the legend of Mechanic Johnson endured. His work became a testament to the unyielding human spirit, that even in chaos, even amid destruction, brilliance could emerge in the most humble places. The roar of that engine was more than metal emotion. It was proof that courage, skill, and a refusal to accept impossibility could change the course of events, and in some small, extraordinary way, the course of history itself. The world remembered the P-51 for its speed, its firepower, and its role in winning the skies. But those who knew the story, who had witnessed scrap become life, doubt become triumph, remember Mechanic Johnson, the man who dared to turn madness into legacy.